Dear students, we are studying the methods of preparation of alkanes, and the third method is decarboxylation of monocarboxylic acid. Monocarboxylic acids are those in which there is only one carboxyl group. Carboxyl group, as you all know, is COOH. This is carboxyl group. So whenever it is added to any alkyl group, it becomes the particular acid of that alkane. So when sodium salts of fatty acids, I must mention that carboxylic acids are also known as fatty acid. Fatty acid means fatty acids are also a subcategory of carboxylic acid. They come under the same category. So we are using the fatty acids with only single carboxylic group. So whenever the sodium salts, you will first prepare the salt of that acid, then they are heated with soda lime by soaking quicklime with the caustic soda and drying the product. They eliminate the molecule of carbon dioxide to make alkanes. For example, here, first of all, the general reaction. You will first change it by reacting it with sodium hydroxide. You know, when you react a base with an acid, it will give you a salt and water. Now we will use this salt. Okay, and then you will react it with caustic soda again. This will take this and this oxygen, sodium, oxygen, sodium, and this whole group. This will become sodium carbonate, and the rest remain will be H and alkyl group, which will become alkane. The catalyst in the reaction is calcium oxide, and a high temperature is required for the reaction to proceed. Another example is given as reaction of sodium propionate. Propionate means a 3-carbon acid. This whole will be removed as, and this hydrogen will move to this, and it will become ethane. So you can see that alkanes can be prepared by decarboxylation. Decarboxy means you are removing carbon dioxide in the form of a salt of sodium carbonate, as sodium carbonate from the system. Now we will discuss about the Kolb's electrolysis method, which is the another method for the preparation. The Kolb's electrolysis comes under the same reaction, that is the decarboxylation. So this was the first reaction, and Kolb's electrolysis is the second type of the same reaction. You will remove the CO2 in the form of CO2. Now this is also under the same heading of decarboxylation of monocarboxylic acid. Generally, what will you do, that you will take the concentrated solution of sodium or potassium salt of that monocarboxylic acid, as we have taken earlier. A concentrated solution means you are taking it in a high amount. Then electrolysis will be in the presence of water. Result will be sodium hydroxide and hydrogen gas. Now this reaction is known to involve certain mechanism. When we will take the example of now potassium salt. When potassium salt of acetic acid, we are taking acetic acid as an example. Because this is a very simple acid, and now we have potassium in place of sodium. So here is water. It will first break into cations and anions. The first step in electrolysis is that the salt is broken into cations and anions. Then they move towards the respective electrodes. So it will be potassium ions and this carboxylate ion. Now first of all, anode reaction. Now at anode the anions will come. This is the anion, so this will come here. This dot and this shows the negative charge. It will be converted into, here is also negative charge. This will be converted into radical. This charge will be removed and this will be left with an electron. Two electrons are removed and two will remain here. Now this radical will further lose its alkyl groups. This is also a radical. Now these two will react with one another and give rise to alkane. Now this is our product, but we'll also study the reaction at cathode. At cathode, the water will get these two electrons lost by this anion, and it will be ionized as hydroxyl and hydrogen gas. The potassium ions which are in the solution will take these hydroxyl groups it will give us 2KOH. So these are our products. 4 products will be produced. So this reaction has a limited synthetic application. It is just you can carry out at the laboratory level, and these are helpful. This specially called electrolysis is helpful in the preparation of symmetrical alkanes. Methane cannot be prepared by this method. Now let us discuss further 2 methods for the preparation of alkanes.